This aluminum part that I was machining had 3 ports in it, and at the top of it, it had some O-ring grooves, and then below that, it had a chamfer that led into the main part of the port, and in the body of the port, it had 3 cutouts that angled outwards. And those cutouts are for some fluid that flows around whatever they're putting in there. And there wasn't a cutter that I could purchase that had the flats for those cutouts with the correct angles. So I needed a custom tool. I could have just made something simple and done something like this that had a flat with the angles and gone in there and done multiple cuts to get those cutouts made, and then also gone in with a tool to put in the chamfer, and then gone in with a tool to cut the O-ring groove. But I was like, you know what, if I need to make a custom cutter anyways, might as well make something that can do all those cutouts in one operation. So I went into SolidWorks and designed up this tool here. As you can see, it's got all of the cutouts that need to be made at the spacing needed for that port. And all 3 of those ports were the same as far as the sizing and spacing of those cutouts. So this tool would just be able to go in there and do all of that at once, including the chamfer at the top and the O-ring groove. So I sent this out to get quoted by some cutting tool manufacturers, and some of them didn't reply, and the ones that did said that they wouldn't be able to make it for me. And I was also getting the idea that if a company did quote it, that it would be a pretty expensive tool. So that was kind of a bummer because I was wanting to get this made out of some carbide, because carbide is a pretty rigid material and I wouldn't have to worry too much about deflection. But since I couldn't get this quoted, and I needed to get a tool made so that I get these parts made for my customer, I went ahead and ordered some M2 tool steel and decided to make this cutter myself. The diameters on the inner diameters of that port are relatively tight, while the cutouts are not. And so I'm going to be going in there with a boring end mill to bring the ID to size, and then just using this cutter to put in the cutouts. So I started out and I turned the profile of the tool on the lathe and polished it a little bit. And once I got the turning done, I took it over to the mill, and I had a manual AccuDex that I used for rotating and positioning the tool for cutting the flutes. And the way I went about cutting the flutes was I went in there with an end mill and I cut the flat areas that would be the cutting surfaces of the tool. And then I went and I rotated it and cut the relief angles around the profile of the shape of the tool with an end mill that went down and cut on the sides to cut those relief angles. So once I got the flutes cut and the relief angles cut, this is what the tool looked like. And as you can see, it had some burrs on the tool. But that was no big deal. I just did a little bit of deburring and knocked those off. And this is what the tool looked like when I got it back from heat treat. And then I went in there and cut the ports, and the tool did a pretty good job. It did knock up some burrs after cutting, so I had to go back in there with my ID tools to clean up the burrs after cutting with this tool, and it worked pretty good. Got the job done. So I hope you enjoyed this video. Have a good one and take it easy.